Alright, in the last video we started to make a game, and we basically got as far as this, where we can draw some things on the screen fairly easily. We can even say if, well, it doesn't matter. So we can draw things on the screen, and this kind of thing generalizes to any kind of static drawing. So it's not so interesting to go over that in a video. Instead, let us look at animations. And actually, if you're using Raylib, then there's a bunch of examples here that show you how to do many things. And one of the things it shows you is an example of how to do sprite animations. So here's an example, and you can turn down the speed of the animation or turn up. But basically, a pixel art animation is a series of frames, of images, and then you just cycle through them at some speed. So that's what we're going to try to set up now. So let's have a look at the assets that we have for that. So we have this character animation thing, and there are some monsters. Those are clearly the enemies. Then there are some things that are called priests, and those will be the player characters, I guess. We don't have anything else, and we're not going to make any art for this. So let's just use these as the player characters. So let's open all of these, and where did they go? They are super tiny. Here's one, here's another. Basically quite hard to see, but there they are. So let's start by, I guess, just loading them. So let's make an array of images. So we're gonna malloc, and there'll be 4 images, and I think we're gonna need stdlib if we want a malloc. Let's then free those. This is of course not final. And then we're gonna load, what is it? It's assets character animation, right? Animation, priests, and it's the idle animation, and it's gonna be v2, and they're called priest. Okay, so so it's actually priest 3 v2, and then it's priest 3 underscore v2 underscore the number. This is going from 1 to 4. So there we go. And now we need some textures, which also is a pointer. And we can also free that. And then we want to say this thing exactly. This is just scaffolding code. It's not gonna be final. So what are the size of these things? File priest 1. It is 16 by 16, as we would expect. And let's just draw them like here. And we're gonna, instead of scale, we're gonna say, let's say, you know what, let's keep the scale. And then we just do that a couple of times. And that's it. Let's see how that looks. Okay, so now we have some. So let's put that one at 300, 400, 500. So now we have the different steps of the animation. So you can see there's like a slight movement. Now we need some way of cycling through them. And basically, we'll keep track of the frame count. And we're gonna say, animation speed. Let's put it at 15. And then we're gonna switch frame count divided by animation speed. Oh, that was not animation speed. Okay, so if it's 0, we draw maybe we can do like this, so like frame number is just this thing. And then the one we're gonna draw is the frame number. And if frame number is greater than 3, we're gonna reset it. So let's see how that works. So now we have a basic animation. It's a little bit janky because if we do this, draw FPS, you can see the FPS is like 15,000. It's completely crazy. So we need to say set target FPS to 60. Even though maybe that's overkill for a pixel art game, but now you can see we have this nice animation. These things out here, I don't know why they are there, but that's a bit annoying. Regardless, now we have a basic animation. Let us see, so if this one is higher, let's try to change it to 30. No, so this is actually not a speed. This is more like a frames per frame. I'm sure there's some name for this thing. I'm completely forgetting it, what it is. Frame counter, frame speed. Now, whatever the case, it doesn't matter. So now, we'll every 15 frames we switch to a new one. So if we change it to every 5, it should go much faster. And every 7th we will do like this. All right. So this is the basics of the animation system, but now we need to refactor it because this is like a really pain in the ass to work with. So let us make a new file that we'll call sprite, and we will include it here. By the way, I'm like doing everything in a single compilation unit and basically a single file, because I'm including it here. That's just because it's the simplest way to do it now. There's no issues with it right now, so we'll keep doing it that way until we hit some kind of problem. That's part of the idea with this series, is to just explore and see what makes sense and what doesn't. Okay. So this guy needs some images, it needs some textures, it needs a number of frames and number of frames per frame. And I think that's it. Now let's make a free sprite thing. And perhaps we do it like this. I think that's fine. So we'll generally use pointers to sprites, because probably we will have to make a lot of them. So I think this is fine, like everything is pointer. Okay. Now we can make an animate function of a sprite, and it should take a frame number. And basically, well, it's not really, we call it frame count. So frame number is frame count divided by sprite frames by frame, and then it will say this thing. If frame number is greater than frame count, then frame number, there's no point in modifying this variable. And then we will say draw. Also, we need a position, don't we? So for now, let's keep the position separate. And since we're using, like here, we use this scale and everything on all the drawing, let's also have a scale here. And then it's simply a matter of calling this function here. And it will be sprite textures frame number, and they're probably all like this, and instead of this guy it's going to be x position y, and let me do something like this. Yes, no, 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 yes, no, 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 yes, no, yes, yes. Okay. So, now we can animate it. We still need loading code. And because of, let's do skeleton 1, v2, and then there's a bunch of things here. They all kind of have the same structure. There's 4 frames in all of them, it looks like. So here, still 4 frames. So in principle, we could give the name, which would be like, yeah, let's do that. Let's do that. So load a sprite, and we'll take a name, and we will need some kind of temporary string. So how do we do that? That's not right. Let's say temp is this. And then we gotta free it. And then we will have to say, isn't there like C printf? It's not printf, it's one of these guys. It's sprintf, I think. Right, so sprintf, and we'll be printing it into this guy, and it's going to be assets character animation. And right, so the name is not enough. We have to say, well, we can say so here it is. So we can say like the parent folder is something, and let's switch on the name. And if it is skeleton, skeleton 1, skeleton 2, or skull, or vampire, then the parent folder is monsters idle, and otherwise it is presets idle. And then we can say here it's gonna be this guy, and let's assume we always use v2, and we'll need this. So it's going to be parent folder, name, and I. And we'll say for I equals 1, I less equal 3. Is it 4? It is 4. Okay, and then should be .png. Now I don't know if this sprintf adds a null termination. Calling snull. Let's just try. Probably it's going to fail. So now we have, well, let's do that. Yeah, so we print it and we'll see what happens. We should return something from here. So for now we'll just return null because we don't actually use it. Right, so in here in main, let us load sprite priest 3. And let's try to see what happens. And you cannot switch on a string. That's unfortunate. Okay, so if this, then parent formula is this, else, and we will probably need to include string.h. Let's put it on top, and let's try to run it. Still some kind of issue. If that okay, so now we have the names that it prints. Okay, so it does add a null terminator, I think. So anyway, so we have the file name now. So we're gonna load it. And while we're at it, we can also load the textures. So we'll just do that. And now that we have that, we should make a sprite and initialize it. Free the temporary variable, and then we return a sprite. Actually, instead of this, I guess we can just do this thing. Should be all right. All right. So let's try this system of loading things. Let's load skeleton1 instead. And it's going to be a sprite and call it skeleton. And then we should also free sprite skeleton. And let's get rid of this code and this code. And the frame count we do need. And yeah, I think that's it. And then let's say animate skeleton frame count, and we'll put it here is fine. And we don't need to free these things anymore. And now there's no skeleton. Where is the skeleton? Data is not valid to load texture. So we'll say file.io, assets, character animation, monsters idle, skeleton1, v2, skeleton. Okay, that kind of sucks. That is annoying. If I were better at Linux command line tools, this would be easy, but I am not. So basically we need to do this for all of them. Now we have a skeleton on the screen and it's doing absolutely nothing. It is doing absolutely nothing. Let's draw text format. I think it is. do that thing. And let's not make it black, let's make it white. Right, so what's happening is this frame number is just increasing and increasing, and that means we eventually end up just on the zeroth frame. So what we'll need to do is sprite dot frame count times sprite frames per frame. So there it is. Now it's correctly animating. And it's a bit fast. It's a bit fast, to be fair. The frame thing is just going to keep increasing. It's a bit strange, but let's say frame count equals frame count modulo 1000. Okay, great. So now I can quite easily load sprites and animate them. Then probably the next thing would be to make some kind of entity. Entity, you could probably call it. And the entity would be a type that has the data both for the graphical display of a thing like a skeleton, but also has gameplay related data such as health and damage numbers. So why don't we just try to do that now? We'll make an entity C. We will include it. And we will type def an entity. The entity is going to have a sprite, and it's also going to have a position. That's pretty good. It's going to have not a scale, that's more like an overall thing, but it's going to have actually, let me just check something here. When we draw it, we say position X. So I also want to scale this. That's right. Similar to how we do it here, right? Yeah, we scale everything. Okay, so tab. So it has some display. It is displayed somewhere, and why don't we give it some health? I cannot think of anything else. So let's do that for now. And there's this thing, but I guess that's all right. What if we make like create skeleton 1, and that will just be this thing with health 10, which is fine. So let's go back here and let's actually start to make something that looks like a room that could be part of the game. So to do that, let's make something called just demo room. Demo room, and we want a draw room, I think. And draw room is gonna draw a room, and it's gonna draw that room, and it's gonna take also a rectangle, which is the window, and it will, and also let's say it also takes a scale. So then let's say, what is the width of this guy? Float width is, I don't want to take up the whole window. I want to take up 16 by well, tile size. Actually, in here we also have some random 16s. So I think we should replace those with tile size. Yes. Okay, that was it. And is there also something here? No. Okay, so in the demo room, we have the tile size times 6 is the width, and the height is also tile size times something else. And then the actual width and height is times the scale. So then I want to say, what's the point where it starts? Well, it should be the middle. But then minus the width, and the y should be the same thing, kind of. And then let's look at the draw. It just takes a position, so we're gonna say like that. So if I go back here and we initialize the graphics, we load a skeleton for some reason. We draw some stuff. Let's not draw that stuff. Let's not animate the skeleton. We can still draw the FPS, that's fine. But now we will draw, and I don't want to call it a room, I want to call it demo room. So here we go, draw demo room. And it failed. And that's because warning, implicit declaration function create entity, right? So we have to put that down here because C is so great. Nothing happens even though I am drawing the room. And how can that be? Right, so the problem is yeah, that's a bit annoying. So let's just do that. Okay. We cannot really draw it in the middle because of the way I set it up. Where it's kind of assuming that the position is some integer of tile indices. So really we would need some other kind of function that draws it at an absolute position. But I kind of like the idea that we think of it in terms of tiles. Okay, you know what? Let's say this is all right. Let's say it's all right. We are gonna go in the demo room and we won't need this stuff. And let's put it like a couple of tiles in the middle. Right, so we have to. Okay, so here it is. Now what else do we need in this? So this is kind of like a prototype for a level. So we have to say load demo room, I think. And then we need like maybe there has to be some kind of data, like level data, that we put things into. Maybe that makes sense. So let's make a level and we'll make a level data. And this level data will contain, for example, a number of entities. So we have a load and then we have an unload, a level. And this will just free data.entities. That's it. Okay, so in this guy, I think we want entity count to be, let's make 2. Then we're gonna allocate some stuff and oops, then we're gonna go here and we're gonna say right, so these are so maybe the entities are not gonna be pointers. Okay, so we'll create a skeleton. We will create another skeleton. And that is it. So let's go into the level. Let's go into main. We need to include level. And then what we will say is, let's get rid of this guy. We will say something like, okay, let's have the level data. Let's load the demo room. And then when we draw the demo room, we will also need the level data. And finally we can unload that stuff. So let's see if that works, and it worked. But now we can actually use this stuff. So we can say for data entity count, let's get the entity and animate it at its position. Now that means we also need the frame count. So I'm kind of thinking that we then need some overall game data, which has, amongst other things, the frame count. And that's going to be a global variable. Maybe we want to do that later if it's like too annoying to pass all these things all the time. So int frame count, and now we can animate them. So that was a bit annoying. So I want to say vector 2 position, sure, but actually this is the position. And then we'll say vector 2 add. So that's actually correct, but now let's place one at 1, 1 and one at 1, 1, 4. I think it's, no, not, but actually 4, 1. Exactly. Great. Now we have a basic system and we're kind of starting to have a way to make levels. So I think in the next video we'll look at character input. Player input is what I mean. So basically controlling a character on the screen. Yeah, I think that's a good thing to do next. So I will see you in the next one. Bye bye.